Okay, hopefully you attempted some of these and you're just out to check your answers. If you attempted them and got stuck, then this will be your opportunity to see where you got stuck. However, the trick is I'm not going to do both methods anymore, so that might be tricky for you. I prefer method 2. I think it's a little bit cleaner. It takes a little bit fewer steps, but I also see those least common multiples, those least common denominators really quickly. So if you struggle with that, you might want to stick with method 1. Okay, looking at question number 3. I see an x squared, I see an x, I see this 1. So I know my common denominator, my least common denominator, or least common multiple is x squared. So I'm going to multiply the numerator and denominator by x squared over x squared. And now I'm going to distribute. 1 times x squared is x squared. 3 over x times x squared, well, this is going to cancel and end up with 3x. Plus, this is going to cancel into here, so I get just plus 2. Look at that. No more fractions. It's gone. So nice. Then I have 1 times x squared in the denominator, which becomes x squared, and then plus 2 over x. Well, this x will cancel with this one, and we'll have just 1x left over, so it's plus 2 times x. Now I'm going to factor the numerator. So what two things multiply to give me 2, positive 2, but add to give me positive 3? So it's a positive 1 and a positive 2. So 2 plus 1 is 3, 2 times 1 is 2. In my denominator, I only have the GCF, so I factor out my GCF of x. I'm left with x plus 2. And then I can see these identical parentheses that can be canceled. So my final answer is just simply x plus 1 over x. Remember, if you're tempted to cancel these x's out, go back, keep this in parentheses so you know this is grouped as one numerical value, and don't try to cancel this out. Right? If you put 3 plus 1 divided by 3, does that really equal 2? Because if you went 1 for 1, that's 1 plus 1 is 2 over 1, that's 2. No, of course not. That's 4 thirds. 3 plus 1 is 4 divided by 3. So you cannot do that canceling. That's wrong. Let's erase it. So this is my final answer right there. X plus 1 over x. Okay, number 4, the first thing you have to do is get rid of those negative exponents. So I'm going to do that first. So I get 1 over x squared minus 1 over y squared divided by, here's my big fraction bar, x over y plus y over x plus 2. Well, if I look at all my denominators, I can see that my least common denominator is going to be x squared, y squared. So I'm going to distribute. If I multiply 1 over x squared times x squared, y squared, well, this x squared will cancel with this x squared, so I'll get 1 times y squared, which is y squared, minus, and then I distribute this one, so this y squared will cancel with this y squared, so I get minus 1 times x squared, right, divided by, now I have to do the same thing in the denominator. X over y, well this y will cancel with one of these y's, so I just have 1 left over, but it's x times x squared y. So that's going to be x cubed y, right? If you're not sure, do a little side note. xy times x squared y squared. Well, this y cancels with one of these, so we get y to the 1, so we get x cubed times y. Plus, this x cancels with one of these, so I get plus y times y squared, which is y cubed, times x to the 1. And then finally, I get plus 2 x squared y squared. Okay, now I have to factor. So my numerator, hopefully, is just an obvious factor for you guys. That's the difference of squares, right? This is the difference of squares. That's y minus x times y plus x. And my denominator is a little bit sketchy here. First of all, it's not in descending order, so we should go from an x cubed to an x squared to an x. So you probably want to rearrange that, but in the same sense of rearranging it, we need to factor out our GCF. So we have an x cubed, an x, and an x squared, so we can take out an x. So I'm going to factor out an x, and I'm going to rearrange. So this one I'm going to keep as number 1. This one I'm going to change to the second term, and this one I'm going to make the third term because it's an x cubed, an x squared, and an x. So I factor out an x, but not only can I factor out an x, sorry, jumped the gun there, but I can also factor out a y. So I factor out an xy of this first one. I just simply get an x squared. I factor out an xy of this term, because I want that to be my second one now, and I get 2xy. I factor out an xy, which is going to be my third term, and I just simply get y squared. So I continue down here because my, oops, that's not a big deal, but because I still need to factor the denominator. So this is still factorable right here. Right? Maybe I'm using too much of the same color. This is still factorable. So I keep my xy out in front. That doesn't change. And now I'm going to multiply, or sorry, I'm going to factor. This is x plus y times x plus y. So I get a 2xy in the middle, I get a y squared, I get an x squared, so there we have it. If you're not sure, pause it, come ask me questions, look at the factoring. This is all basic factoring you should have seen already or that we've done. So then you can see we can cancel y plus x, x plus y. It's the same thing because it's positive signs there. So these cancel each other out. So my final answer is y minus x divided by xy times x minus y. That's it. There's nothing else you can do. You are done. Okay, let's try number 5. Okay, number 5 looks scary, but it's not. It looks scary, but it's not. Remember, these have a whole number of 1 underneath them. So very simply, what is the what is the least common denominator? Well, the least common multiple or least common denominator is k minus 2 divided by k minus 2. And look how nice it's going to be when we get rid of that k minus 2 denominator. If I distribute k times k minus 2, well, nothing cancels because this 1 doesn't cancel. So I have to keep k times k minus 2 plus this plus sign. Well, this k minus 2, when I distribute it, will cancel with this k minus 2, so I get a plus 1. Now look how much simpler that numerator is. The second one, when I multiply this k squared over k minus 2 times this k minus 2, well, these are going to cancel, and I would just be left with k squared. And then I can't see, is that a minus sign or it's a plus sign right there? Just wanted to make sure. So then I have a plus sign, and I put plus 1 times k minus 2. Well, 1 times k minus 2 is just k minus 2. So obviously my numerator is going to distribute. I'm going to get k squared minus 2k plus 1 in my numerator, and I have in my denominator k squared plus k minus 2. Now, can I cancel? No, not until I factor. So I'm going to factor my numerator, I'm going to factor my denominator. What multiplies to give me positive 1, but adds to give me negative 2, that's minus 1 minus 1. What multiplies to give me negative 2, but adds to give me positive 1, that's plus 2 minus 1. I can cancel identical parentheses, so my final answer is k minus 1 over k plus 2. And finally, the last one, best for last. Looks like a doozy, so let's try it out. So I look at my denominator, and I have an x minus y, an x plus y, an x minus y, an x plus y. So I am going to not multiply my numerator times x plus y, x minus y, and I'm going to multiply my denominator times x plus y, x minus y. Because those are the two factors of my top part of my fraction and my bottom part of my fraction, the numerator and the denominator. So once you distribute, this x minus y will cancel with this x minus y, so I have x plus y times x plus y left over. Then I have a minus sign here, so be careful. So when I distribute here, the x plus y will cancel with this x plus y, and I'd have an x minus y times an x minus y. Except I'm going to go ahead and bracket that, because I don't want to forget to distribute my negative through this simplified answer once I go ahead and multiply it all out. But I won't do that till later. The second part, this first fraction times my least common denominator, least common multiple, I will cancel this x minus y with this x minus y, and then I would have x plus y times x plus y, again, looking familiar. Except the only thing different in the denominator is that I have a plus sign in here instead of a minus sign. So I'm still multiplying again, this x plus y, and this x plus y will cancel, so I have an x minus y times x minus y. I'm not going to bracket this parentheses because it's a plus sign here, which means I don't have to change any of those signs. So now I'm going to multiply this out, FOIL it out, and combine my like terms. So it's going to be x squared, oops, I missed a plus sign there. Oh, sorry, or did I? Yeah, I did. So x squared times x plus xy plus xy plus y squared. So that becomes x squared plus 2xy plus y squared. Over here is a little side note. I would get x squared minus 2xy plus y squared, except I need to distribute my negative. So that becomes a minus x squared. It becomes a plus 2xy. It becomes a minus y squared. So be careful. Make sure you distribute that negative. My denominator then, I multiply that out again. I get x squared plus 2xy plus y squared. I multiply this out because of the plus sign. All those signs stay as their original, like these up here. And now I combine my like terms, and I try to simplify. Well, this is nice. My x squared cancels with the negative x squared. My positive y squared cancels with the positive y or negative y squared. So I only have a plus 2xy plus 2xy, which is 4xy. Now my denominator doesn't quite become that nice, but this positive 2xy and this negative 2xy cancel. So I have 1x squared plus 1x squared, which is 2x squared. I have 1y squared plus 1y squared, which is 2y squared. So can I cancel anything? Sure. Because I can factor in the denominator. So what can I factor? I can factor out their GCF. So the GCF of 2 comes out. And then you can see these are factors because it's all being multiplied together, So 2 goes into 4 2 times. So my final answer is 2xy divided by x squared plus y squared. And that is it. So if you were having difficulties understanding this because you were sticking with method 1, then please come in and see me. Maybe we only need about 10 minutes to figure out what mistake you were making. Or perhaps this convinced you that you should go to method 2. I don't know, it's up to you. It doesn't really matter as long as you are finding success with your method. So if you're not finding success, you might want to switch it. But if that's frustrating to you, then come see me and I'd love to help you out. Have a great afternoon and a great weekend, and I will see you next week to review for the test. Bye.